Hi all, I am K. Surya, working as Assistant Professor in the Department of ECE at SNS College of Technology. So in this video, let us see about discrete time signals. So first we should know what is a discrete time signal. So it is a signal which consists of values only at discrete points of time. So the amplitude will not be a continuous value. Only at particular intervals of time you will be having the values of the amplitude here. So this is shown in the diagram here. Generally discrete time signals are represented by n and continuous time signals are represented by t. So some of the standard discrete time signals are unit step signal, unit ramp, unit impulse, exponential and sinusoidal signal as we saw in the continuous time signal. The only difference here is in continuous time signal, the signal will be a continuous value. So you'll be having the amplitude for each and every instance of time. Whereas in a discrete time signal, you'll be having the values only at particular time intervals. So first we'll see about the unit impulse signal. So graphically it is represented as a single non-zero value. So typically it is 1, n is equal to 0 and 0 elsewhere. The impulse signal is used extensively in system analysis, particularly in determining the impulse response of a system. So impulse function is denoted by del of n, which is equal to 1 for n is equal to 0 and 0 for n not equal to 0. Next one is unit step signal. So the signal is 0 for all negative values of n and only for all non-negative values of n it is 1. So it represents a sudden switch from 0 to 1 at n is equal to 0. So the unit step signal is useful for representing the signals that start at a specific time period. So it is denoted by u of n and given by u of n is equal to 1 for n greater than or equal to 0 and 0 for n less than 0. Next one is unit ramp signal. It is denoted by R of n and it is linearly increasing function with n greater than or equal to 0 and for n less than 0 it is 0. So it represents a gradual increase in the amplitude over time. So it is represented by R of n and given by R of n is equal to n for n greater than or equal to 0 and it is 0 for n less than 0. The next one is an exponential function. So exponential function is the form of x of n is equal to e power a n, where the shape of the exponential depends upon the value of a. So here you have three conditions. A is less than 1, a lies between 0 and 1 and a is less than 0. So when a is less than 1, the sequence will grow exponentially as shown in the first figure. When it lies between 0 and 1, say example zero point 0.5, then the exponential function will decay exponentially, and when a is less than 0 then the exponential sequence will take an alternating signs mm, as shown in the figure 3. So there are three types of exponential cases here. Next one is sinusoidal signal. So sinusoidal signal is given by say a cos omega n plus phi or a sin omega n plus phi, where a is the amplitude or magnitude of the oscillation, omega is the angular frequency which is in radians per sample, n is the discrete time index which is an integer value, and phi is the phase shift. So sinusoidal signal in discrete time is shown here in the diagram. Some of the applications are it is similar to the continuous time signals. Here also it is used in signal processing in DSPs for the processes like filtering, sampling and reconstruction, spectral analysis, modulation, demodulation. Say it is used in communication systems like digital communication systems for channel equalization, for SPED spectrum. It is also used in OFDM and in image and audio processing it is used for, say, image filtering and enhancement and audio processing, speech recognition. It is also used in control systems for uh, digital control systems, real-time control, and in other applications like geophysical signal processing, biomedical signal processing, time series analysis, data compression, in computer vision. These are all the applications. So let us take up some assessment questions. What is the mathematical representation of a unit impulse signal? Yes, we know that del of n is equal to 1 only at n is equal to 0 and it is 0 otherwise. So which of the following represents a unit step signal? Yes, the answer is u of n is equal to 1 for n greater than or equal to 0 and 0 otherwise. The discrete time function defined as u of n is equal to n for n greater than or equal to 0 and u of n is equal to 0 for n less than 0 is a unit ramp function. Thank you for watching this video.